Good afternoon. Welcome to the Bulkley Valley Research Center's afternoon virtual seminar series. My name is Dawn Hansen. I'm the Executive Director of the Research Center, and we are pleased to host Len Vanderstar today, talking about Willow Forage and how they're enhancing moose winter range. I'd like to acknowledge that I'm hosting this seminar from the traditional territory of the Gidimt'en clan of the Wet'suwet'en Nation. And I'm sitting on the banks of the Bulkley River this afternoon. Appreciate the support from our funders, Bulkley Valley Credit Union, Bulkley Valley Community Foundation, the Provincial Government Gaming Fund, as well as all of the partners and funders that make research that the center does possible. And I also appreciate the time and the willingness of researchers from a variety of projects and places and institutions to share their work with us so that we can host these seminars and share out information and knowledge. They've been a really great series. And I think with that, we'll move into Len. I know Len as an adventurer more than a biologist. He has done several trips to Africa and is supporting communities down there. And he is also a bit of an epic peak climber. But super interested to hear today, Len, about your biology work. Thanks very much.
Thank you, Dawn, and thank you everybody for attending. I really appreciate accommodating myself in a Zoom presentation. So we're going to talk about a moose enhancement project that we did on the north side of Babine Lake, just southeast of Smithers Landing. The objective of the work was twofold. First of all, producing willow sprout biomass from felling and hinging of Scouler's willow to support moose forage production. And the second objective was basically an operational research trial focused on assessing whether or not seasonality of treatment, so winter, pre-flush, post-flush, or elevation of treatment or treatment method had influenced sprout biomass production and shoot nutrition. In addition, in the winter months, moose habitat utilization, browse availability, and browse intensity surveys were conducted in the winter of 2021 and last winter of 2022, basically to assess if there was any noticeable difference in moose foraging behavior. The monitoring study is designed to be repeated in 2023 and 2024, and in future 3 to 5 year increment cycles, depending on funding availability. This Scouler's Willow Forage Enhancement Project and associated operational research study would not have been made possible without the combined funding of the Habitat Conservation Trust Fund and the Forest Employment Program, along with support from the Bulkley Valley Rod and Gun Club and Lake Babine Nation, on whose traditional territory the work was conducted on. CERN, BC, that's a Society for Ecological Restoration, Northern BC, provided initial seed money for the project proposal work. Special mention is extended to Jeff Warner, Amanita Kuzmins, and Toby Anaka for their support and biological expertise. Jeff was instrumental in advising myself on nutrient analysis to make the assessment part of the project more efficient and economical. Amanita was very helpful in assisting myself in field card refinements and reviewing assessment methodologies, and playing a latter role regarding the relationship between total nitrogen and crude protein. Toby was instrumental in ensuring the government Skeena Region's support for the project and asking questions of clarification that resulted in a more robust report. Former colleague of mine, Jonah Keim, he now works as a statistician in New York. He developed the best fit regression equations to enable subsequent biomass calculations. Carl Schwartz, you might know, he's a well-published moose biologist and statistician, was phenomenal in a statistical analysis of the chemical analysis of current year shoots, which made me deep digger into statistics than I ever wanted to go before. Bit of a black hole, that kind of math. But anyway, These in-kind services from Jonah and Carl were very much appreciated. A sincere thank you is extended to Lisa Wood of UNBC for allowing use of her lab, notably the Wiley Mill for sample processing. The provincial government's chemistry services lab in Victoria was very helpful in advising me in sample preparation and timely delivery of analysis results. Dave Hooper, president of the Bulkley Valley Rod and Gun Club, was diligent in all administrative matters and public relations. And his enthusiasm for wildlife habitat enhancement continues to be second to none. Most importantly, it's the boots on the ground that makes this project delivery possible, meeting project milestones in a timely manner, ensuring quality of performance and high safety standards, and being physically capable of demanding work in such difficult conditions and terrain. So brothers Jack and Lloyd Hooper of DOJ Holdings and my brother Len Vanderstar of Ganakwa Forestry Services fully delivered in this regard. So on the screen here is a Google Earth image of Old Fort Mountain operational research study. So what you see here is the yellow highlighted areas are our winter season treatments back in 2021. And we have lower elevation around the 700 to 850 meter mark above sea level. We have the mid elevation band around 840 to 950 meters. And then we have an upper elevation band at around 1,000 to 1,150 meter elevation. The blue highlighted areas is our pre-flush treatments. That's just pre-flush. So it would be late May, early June. And then our post-flush being the green areas, where it would be later June, mostly into just early July. So we have a total of 9 treatment units that cover 3 treatment seasons: winter, pre-flush, post-flush, across 3 elevational bands, lower, mid, and upper slope. The total area covered here by this treatment was 630 hectares. So fairly substantial ground. In addition to that, we had money to do some more treatment that wasn't part of the operational research trial, but kilometer 34 on the Babine Lake Road, we treated, kilometer 37 into the Nilkekwa spur here. We had 16 hectares here treated. It was an old fire. It was wind road back in its day, and as the debris and the wind rows rotted, Scouler's willow came on site, and we had these rows of Scouler willows. So we went and did a fair amount of hinging and felling of trees there for moose enhancement. In addition to that, we treated additional 60 hectares in the Grinnell Community Forest area, as you see in front of you here. And that, again, strictly winter treatment, just because of the nature of the ground and the difficulty would be impossible to go through that vegetation during the snow-free season. So that was all done on snowshoes as well. In total, between these 3 treatment areas, we treated approximately 60,000 Scouler willow trees. So either they were felled completely, like severed from the stump, or hinged, where we dropped the tree, but there was live cambium tissue connecting the bole of the tree to the stump. So a total amount of 720 hectares of treatment. 630, which were in the operational research trial of Old Fort Mountain. So after the first growing season, after post-treatment, that's only the first year. So, the shoots are just developing. They're not that big yet. We had estimated that over and above what would otherwise occurred if we didn't treat, we produced an additional 97,000 kilograms wet weight of current shoots. And that's basically 115 kilograms per hectare enhancement. So transits were established through these treatment units, mostly prior to felling operations. Selected Scouler willow trees were flagged for retention. These are what we call our controls, and that's where the red ribboning you see in front of you there. Or they had green ribboning, just right behind my brother's hat there. Those trees were going to be either felled or hinged, and that would be based on faller discretion for a safety perspective. Each of these sample trees had GPS coordinates taken, so we can revisit them in subsequent years. So if it is these trees that we conducted the fall post-leaf drop morphometric assessments. In total, we had pretty close to 275 trees. Counting, we had 274 sample trees amongst the 9 treatment units. Basically 30 sample trees per treatment unit. So 10 trees that were what we call our controls or residuals, 10 that were hinged and 10 that were felled. And these are the trees that we used to determine some of our regressions in terms of biomass production, as well as samples for our nutrient analysis. So for each sample tree, the number of stump sprouts and bull sprouts were separately counted if they were greater than 25 centimeters in length. And we didn't go with sprout length less than that because they basically wouldn't really contribute much to a biomass accumulation. So we use sprouts, if they exceed equal or greater than 25 centimeters, we counted them. Also, their corresponding average shoot length was determined and recorded. And we took, based on 59 sample shoots of various lengths and current basal diameters, we developed regression equations. So we could basically, it was for the purpose of determining what the average biomass weight would be, both wet and dry weight, based on shoot length. Now, knowing by treatment unit the number of hinged and felled trees based on faller counts, their respective average shoot biomass, inclusive of the controls or the retained trees, calculating the net gain of shoot biomass through forage enhancement work is readily achievable. For nutrient assessment, current shoot samples for the upper 20 centimeters of the shoot was selected from each flagged tree, and these were taken for elemental analysis for comparing type of treatment, seasonality of treatment, and elevation of treatment. Now the focus was on total nitrogen because we used that as a surrogate for crude protein content and nutrient availability. It was the least expensive nutrient analysis that would give us an indication of nutrition. So based on 9 treatment units by 3 treatment types, so we had 27 batch or composite samples for analysis. Photos were also taken for a subset of these sample trees for visual comparative work taking place and into the future. So a couple of highlights about the project. So we treated overall 720 hectares. Our target prior to starting the project was 720 hectares. So we were pretty good with achieving our target objective in terms of treatment. So actually getting the work done on the ground. One important conclusion here, and there's not been a lot of publication around when's the best time to treat willows. It's very limited amount of literature out there. But based on previous trials, we suspected that there would not necessarily be a measurable difference between seasonality and treatment. But anyway, what we found out from our first year assessment, this is an interim report, I have to let you know. But based on after our first year post-treatment, field assessments and lab analysis show that seasonality, i.e. the timing of treatment, or the elevation treatment do not affect shoot biomass production or nutrition to any measurable extent. Other than with one exception, post-flush treatment, shoot biomass production was a bit lower than winter and pre-flush, just because of the recovery time for the trees that were hinged and felled for the first growing season. But that will almost be negligible in the second and third growing season from what we've seen in the past. This is the first time that I'm aware of that regression equations for Scouler's willow have been developed based on shoot length to determine shoot biomass production by treatment area and by hectare treatment based on faller counts of trees hinged and stumps severed. The uniqueness about this methodology is that we're not doing any fixed radius plots. It's almost impossible and too time consuming to do that after you actually fell these trees all over the place. So this is why we do transit surveys and the methodology that we employed here. Because the objective is basically just getting an estimate of biomass production and some nutrient sampling. what we found out, which is supported from our previous trials elsewhere in previous years, significant willow shoot biomass, i.e. moose forage production, we increased it by 335%. So basically between 3 to 4 times increase than what would otherwise occur if we did not do the hinging and felling treatment. And this 3% increase is just based after the first growing season. So that will actually increase as the shoots develop more vigor and more biomass. So it's pretty good results after the first growing season. And most importantly, no reportable accidents by field crews or no reportable COVID-19 cases as was done during the COVID epidemic. So thus care and attention to safety plan was achieved. Now, this is a little bit of a summary table here. It's kind of interesting to take a look at that. So in the treatment unit area here, the upper table, you can see totally we treated 630 hectares. Over 32,000 Scouler willows were hinged, and over 16,500 were felled. So close to 50,000 trees were treated. The percent hinged trees compared to felled were 66%. So overall, the ratio to hinged to felled trees was 66 to 34. And so that's good because, you know, if you can keep the bulls alive, it's you get more production than just felling a tree in terms of biomass. What's really important here is that when you go into these sites, these are a bit of mostly a deciduous complex with some conifer, and they're very important for wildlife, and notably avian bird communities like warblers that nest in there and feed on insects. So we don't want to take down every Scouler willows tree. I mean, these trees are, the sites we're treating, these trees were averaging 120 years old. So, you know, pretty well old growth Scouler willows. So we always try to retain about 25 to 35% of those trees on site without felling or hinging. So we have a percent retained figure here on the right column. So here's an example of a tree that has been hinged. So you can see that there's live cambium from the stump to the bowl. And this is the first season post-treatment, first growing season. You can see that we've got some pretty good shoot production based on the vigor of the adventitious shoots that were coming off the bowls here. And you can see that the moose were already starting to nip away on the tops. So they seem to like the tops, the highest nutritional content. So even before the winter season, they're starting to get in onto the shoots. And some of these photos that were taken basically towards the end of October right now. You can see a touch a little bit of snow on the ground. We get some early snows, and so yeah, late October we did these post-flush, post-leaf drop morphometric measurements. So here's an example of some of the hinged trees with live bolls on the ground. You can see some of the shoots coming off the bolls here. So we're getting some pretty good 1 meter, close to 1 meter shoot lengths off the bolls already on this particular set of trees. So that's pretty good. Sometimes they're only 25 centimeters. Sometimes you get some 1.5 meters. This other photo here shows a tree that's been hinged. So there's live cambium, and then also you can see that the stump sprouts are pretty significant with my brother Ron, field assistant, in the background there. One of our lower elevational sites, a little bit more open than the others, but still, just to give you an idea what the country looks like there. Historically, Lake Babine Nation had burnt the south aspect, so it created the habitat it's very plentiful habitat supply for both bears and moose as well. So just to give you an idea what the terrain looks like a little bit there. And this is a picture of some hinging that's occurred on site there. Now, one thing that we wanted to look at is a correlation of shoot weight versus shoot length, because we go and look at a sample tree and we say, yeah, the average shoot length is such and such, say it's 150 centimeters. we can get a pretty good idea that, in fact, the weight of that shoot would be 100 grams. Okay, so we looked at different regression equations, and we found out that the natural that's the natural log to log was the best fit. So that is the black line that you see there, and then we basically used that best fit regression for correlating the average shoot length to shoot biomass. In this case, a wet weight relationship. We also did a dry weight as well. Now, one thing to keep in mind is that when you have shoots coming off the stumps, you will get single stem shoots, and you also get what we call multi-stem shoots. So there's a distinct difference between the biomass for their shoot length between the two. And you can see that on the left side, that the round ones are, those are the multi-stems, biomass versus shoot length, and the triangles are the single stem. So you can see that there's a difference between the two. Now, for the purpose of this interim report, first year assessment, post-treatment, there wasn't a lot of multi-stems to worry about. In the future assessments, we would have to separate the regressions. So what we did is we just bulked the two of them together for this assessment for estimation of biomass production. And that's the graph you see on the right with the log-log relationship. So we basically used that, just combined the two and came up with one regression. So it's a right regression equation that we used for estimating biomass, that when I refer to 150 kilograms per hectare production, we used the regression equation on the right. So here's a picture of a multi-stem, just to give you an idea. You can see that it has a number of single stems based on one current year shoot. So that's why in future years, when we see more multi-stems growing, that we would want to separate the difference to get a more accurate estimate of biomass production. So here's some results here for the various treatment units. These UWs, that means upper winter treatment unit 1, middle winter, lower winter, upper summer, middle summer, lower summer, and these are pre-flush and post-flush summer treatments. So you can see here that from a graphical bar graph perspective, you can see that on average, we're either doubling or quadrupling biomass production that would otherwise not have occurred if we did not treat those areas. So some areas we doubled, sometimes we quadrupled, but on average, we've increased the production by a little over threefold. So pretty good results. Now, where does that lead us to? Well, okay, so considering that a moose eats 15 to 20 kilograms of twigs a day, and we're talking wet weight here, about 15 to 20 kilograms. And if you look at the winter browse season, that's from mid-October to mid-May. If you count the days, you come up with 211 days. So they're eating 15 to 20 kilograms of twigs over a 211-day period. And if you assume that they eat 50% of the annual shoot biomass, and that's more or less realistic from what we saw based on our observations when we did these winter surveys at the end of February. It could be more than that, but just assuming they eat half of it. The biomass production associated with treating 630 hectares increased the carrying capacity for the land for an additional 13 moose. So that's pretty good. So depending on future browse intensity, the carrying capacity will tend to grow over a period of time of 10 to 15 years as the shoot production increases, and then begins to decline when the new growth becomes out of reach for effective moose browsing. Now, here's a really important point. Less intense moose browsing shortens the window for enhanced carrying capacity. The reason being is that these shoots can grow out of reach out of the moose within 5 years if they're not club browsed. So if you have a low density moose, the effort in terms of enhancement may not be as beneficial as if you had a higher browsing intensity that would keep these shoots in more of a club browse situation for longer longevity for forage supply. So as such, Scouler Willow forage enhancement is most effective while there's still a healthy moose metapopulation in the area, and where available browse is limiting for the area moose population. So they're going to focus on the enhanced forage and keep it more or less club browsed. And this was the case at the Old Fort Mountain site. There was lots of moose, and there was also a limited browse. So we knew the enhancement work in that area would be beneficial and have a longer duration. By the way, in the past, we've gone back and treated other enhanced sites. It's usually around after 15 years, you basically have to go back and retreat. So just to give you an idea how long the enhancement window would actually occur. Again, just a bit of a difference between looking at, on average, with all the treatment units, what the biomass production was in relation to fully cutting or felling the tree versus hinge tree versus residual, where we had no treatment. So you can see that even after the first growing season, because we had some of the live bulls, we're getting increased biomass production over just a felled tree. That will definitely increase over time. In fact, what happens, the bulls will substantially outnumber biomass production of stumps, in year 3 to 5. But after the first growing season, they're pretty well even Steven, slightly more on the hinged, but that will change. Pretty well also, this tells you that the oven dry weight's about half of the wet weight. So you're looking at here, right after the first growing season, we're roughly getting about, that's what is that, average unit? That's in grams, the kilogram here of forage supply per tree. Oven dry weight. Okay, into some of the analysis. So won't get too far into the statistics. This is just one example of one analysis that Carl did. But so we really focused on nitrogen as a surrogate for crude protein content and nutrition. So in terms of elevation, lower, middle, and upper elevation, you can see there's not a lot of variation with the nitrogen, total nitrogen content in the upper 20 centimeters of our sample twigs. In terms of seasonality of treatment, there's a little bit of variation, but the intervals are still overlapping, the confidence intervals, so again, not statistically significant. In terms of treatment type, whether it was felled, we would say cut, hinged, or control, it looks like the nutritional content, at least in terms of total nitrogen as a surrogate, seem to be higher in the treated areas, treated trees as opposed to control. But again, the overlap on the confidence it's not different enough substantially to state that we could really say there's a measurable difference statistically. And they were based on two different types of analysis. One was an augmented factorial analysis, and the other one a regular ANOVA. So from this, there appears to be no reason why Scouler Willow treatment cannot occur in any given season. So it shouldn't be inhibited by season or by elevation, or whether the trees are hinged or cut. It doesn't seem to affect the nutrition or even the biomass production. Jeff Warner wanted to look at the relationship of total nitrogen and total sulfur. So he ran a correlation here, and it's a pretty good, R-square value of 0.7. There's a very good correlation between total sulfur and total nitrogen. And basically the reason why is that because you need sulfur to synthesize chlorophyll. It's also important for the production of amino acids. So it's not unexpected to see a good correlation between total sulfur and total nitrogen in plant material. This is an example of a summary of field cards. So in 2021, we did a winter survey, and then we repeated the survey on the same site on the same transit in year 2022. Where you see the red font is where we noted some differences between those two survey years. So snow depth slightly a little bit different, but in year 2021, we had a 14-day, what we call a habitat utilization window. In other words, there wasn't enough snow that could bury moose tracks or pellet piles or moose beds. So we basically had a 2-week observational window when we did this survey at the end of February. So we were looking back and we do these counts. In 2022, we actually had a 4 to 5 week window, just because we had no snow for about a month, and there was a bit of a prolonged thaw period prior to our assessment as well. So if you think of that, let's take a look at the tracks here. In 2021, we counted 66 tracks per hectare based on the transit habitat utilization window that we had 2022. If apple to apple comparison, we expect maybe 120 tracks per hectare, but in fact, we achieved 200, over 200. So that told us that there's definitely an increase in terms of habitat utilization from a track count perspective. Same thing with beds. In 2022, if it was similar to the pre-treatment 21, that was pre-treatment 21, we expect about 6 tracks per 6 per hectare. In fact, we were getting 60. So we did see an increased uptake on habitat utilization following treatment. And so that the habitat utilization went from moderate to high. Again, the browse species availability, not much change there in terms of browse intensity. No real substantial change on the Scouler's Willow because they were still using it, but you know, the shoots were just developing, so there was definitely more use, but not enough to really change it to very high. Now, one thing really interesting here, if you look at high bush cranberry HBC, the browse intensity in 2021 was high but nil in 2022, and this is why it's important to keep track of snow depth and climatic conditions. It's not because the moose were snubbing what the most desirable forage species of high bush cranberry was. It was because originally in 2022, the snow depth was high enough that it actually covered most of the high bush cranberry. And then with the subsequent melt, the high bush cranberry became exposed for the moose to start browsing on it. But that didn't really come available for moose until at the time we did our survey. It only started popping its head out of the snow at that time. So that's why there was very little browse. It's just because of how the snow had covered the high bush cranberry prior to our survey. So those are the kinds of things you want to be looking at because there's the variables involved here and you have to keep track of what the possibilities are. Just a picture here of some winter hinging and felling work. This is one of our upper winter polygon where we hinged some work. You can see that the forest type there was predominantly Scouler's Willow with some aspen and then some conifer, mostly spruce, and then some fir as well. All this work is done on snowshoes. It's pretty taxing. You have to be fairly physical to deal with the rigors of this work. You can see that, by the way, this combination of our snowshoe tracks here from this aerial drone shot, as well as some moose tracks here. But that just gives you an idea post hinging and post felling what the stand looks like. So fairly open canopy, by the way. Again, there's a real advantage doing this work in the winter, by the way. It's just because of access, it makes it easy. But the same thing is that the moose, once they know these trees are down, they'll eat it down, all the twigs on the crown, right down to 1 centimeter diameter. And that's what you've seen. This was a crown of a Scouler's Willow that was completely nibbled down at the time of hinging and felling. And you can see that they've been really comfortable in their moose beds all around it as well. They just love it. So it gives them an additional forage supply during the winter that would otherwise not be available. So that's one of the advantages of hinging the winter, is that you're giving them an immediate forage supply that otherwise would not occur necessarily in the summer months. So the whole idea is to have happy moose. So some findings and lessons learned and future direction if we do this work into the future. And this is now my personal opinion based on, this work and then, about 10 years of doing this off and on with guide outfitters and so forth. But seasonality of Scouler's willow treatment has no bearing on shoot or sprout nutrition. So good point. So this is from this interim assessment. Of course, we're going to do another assessment here, hopefully next winter, contingent on HCTF funding, and hopefully that will continue to support this interim finding. Also, elevation is not a limiting factor for treatment. The one thing we really noticed, though, we did some of this winter hinging, and you recall back in 2021, in February, we had some temperatures exceeding minus 30 Celsius. We were going to minus 35, 38. Pretty cold conditions to do this work, I must say. But anyway, we definitely had a solid week of this. And we were out there. I was winter camping at the time as well. So we were out there snowshoeing onto these sites and so forth. But the fallers were falling, and we noticed that it was very difficult to hinge trees at that temperature. They would snap and not necessarily hinge. In addition to that, we had the ones that we successfully hinged, we had a 30% hinging failure, meaning that the bulls died by the time we reassessed them in the following fall. And what's this high cambium mortality, we suspect is likely due to cambium freeze drying at those cold temperatures. So we would recommend that this work not occur if you're exceeding temperatures below 30 Celsius, because you'll get at least a 30% failure of your hinged bulls. One thing that you have to train the crews up to if you want to get a biomass estimate using this methodology is that the crews have to tally the number of felled and hinged trees that they do. And it's a bit of a distraction for them. So they have to be careful, safety comes first. So they try to keep a count in their head, and then every time they move from one patch to another, then they will tally the number of felled and hinged trees. It takes a bit of training. They get a little resistant up first, but then they get into the groove. But just one thing to be aware of, that for this biomass estimation to occur, they actually have to tally the felled and hinged trees. The other thing is, I mentioned earlier in the previous slide, winter felling of Scouler's willow has the added benefit of supporting immediate moose winter foraging needs. Now, one thing I've seen here in the valley, you've probably seen it yourself if you're going up the Nordic Center or elsewhere, we've had an epidemic of what we call the willow borer or the willow weevil, and it's basically annihilated and killed the vast majority of Scouler's willow anywhere it occurs. It's spread right through a Highway 16 corridor up Highway 37. It's moved substantially through a number of linear corridors for service roads, pipeline corridor, transmission lines, and so forth. And what we've found to date is that, looking at these attacked trees, they eventually succumb to mortality. So you may find shoots resprouting, but eventually they get reattacked, again draining the starch reserves and the stumps, and eventually these larvae go into the root collar and down below, and eventually the trees die. So what we've noticed here is if we actually treat some of these areas, and that's a fair amount of areas now throughout the region that are infested, it would likely render this enhancement work useless within a few years due to very high or complete mortality. Now, just to let you know that about 3 years ago, there was no willow weevil on the highway from Topley to Grinnell. And as of last year, now the willow weevil is in Grinnell and beyond. And now it's in the Grinnell Community Forest, and it may be very well into those 60 hectares that we treated this year. We're going to take a look, or sorry, last year, but we'll take a look at it and see where, but we suspect it's spreading now. It's unfortunate, but Toby's doing proposing some experimental work here to see if, in fact, some hinging can save these trees until the willow weevil can finish its infestation. However, the jury's still out on that one. So there may be some more work along that line. But I think the only way this thing is going to subside is through some natural biological control mechanism. So of course, this is one of our followers, Lloyd Hooper. Of course, a good photo. So of course, we're going to have to put that in. It was in the 2023 edition of the Woodsman calendar. Yeah. So, okay, putting that humor aside, favorite food of moose. Well, on the left here, they really love this Douglas maple. So it looks a bit like Saskatoon, but Douglas maple, boy, they just club browse that to no end. Number one favorite candy for moose, not necessarily the most abundant to forage supply. Of course, Scouler willow is, and red osier dogwood is. Those are the two main species of forage supply in the Bulkley TSA. But also moose as a second favorite candy, they really do like the serviceberry. So Saskatoon, and you can see extensive club browsing on that on the right. And you can see Babine Lake in the background on that photo. And what else here? Okay, don't forget that moose do like subalpine fir, Aves lasiocarpa. You'll find bull moose all the way up in the ESSF, wintering all winter long. And they've been more than happy of being in snow depth that they can't move around in, and just kind of belly walk in between subalpine fir all winter. So you have a high percentage of mature bulls at high elevation, but the cows and calves have to come down low to the valley bottoms because of snow depth. The calves definitely, or the yearlings definitely cannot take snow depth more than 1.5 meters. But subalpine fir, club browsing along that is very common where you see moose. So moose eat fir, deer eat cedar. So that's the difference. Again, favorite food of moose. Again, we're looking at the Scouler's willow. They will not only eat shoots, they will bark gnaw as well, as you can see here, whether the trees have been pushed down by snow breakage and or just eating the bark, the inner bark, the cambium off the bolls. Now, keep in mind, if we don't do any treatment, winter breakage will break these trees and create sprout production as well. So there's always some amount of sprout production, whether you enhance or not, but enhancement definitely increases it. So that's about it. So I'm going to open the floor for questions and discussion.
Super, Len. Thanks very much for sharing that.